Hi there, everyone. Welcome back for our next session from the Encryption Consulting virtual conference. I'd like to welcome Paul Hampton from Thales to give us the next session, which is titled Flexible Crypto with Uncompromised Trust, Security to Meet Your Business Needs. Paul spent over a decade working in the banking industry, launching and securing online banking and early fintech initiatives. He joined SafeNet in 2011, later acquired by Gemalto, and led the fast-growing payment cryptography product business for 8 years. After Thales' acquisition of Gemalto, Paul was chosen to manage Thales' cloud cryptography service platform. Paul has over 20 years of experience in the industry and holds a number of certifications, including CISSP and CISM. Paul's specialties include information security management, cryptography, software engineering, and authentication. Before we hear from Paul, we'd like to share a special message from our sponsor, Thales.
In a world that's changing faster than ever before, securing data, identities, and software has never been more important. That's why trust in the digital services people use every day is crucial. And when it comes to the security of data, identities, and software, the most trusted companies and brands rely on Thales. Whether it's helping businesses around the world provide trusted access for thousands of remote employees, enabling organizations to accelerate their digital transformation in trusted cloud environments, helping companies transform into trusted software providers, or securing payments for billions of trusted digital transactions every day. At Thales, our mission is simple. We help businesses, governments, and organizations all over the world build a future we can all trust.
So, hello everyone. I'd like to start our presentation with an overview of what we will be talking about today. Of course, first we will introduce the topic of cryptographic flexibility and talk about some of the key points to consider when deploying cryptography and how you can best ensure flexibility for your organization. We'll then go on to talk about Thales hardware security modules and how they can assist in that journey and bring flexibility to your cryptography and key management. After that, we will then move on to talking about some use cases, so some example deployments of cryptography and key management infrastructures across organizations, and indeed some common examples that Thales see as we are working with our customers to deploy both cryptography and key management. And so, moving our slides on, I'll start by saying flexibility can mean different things to different people. And so for some, this is all about different algorithms. Should I use elliptic curves for my digital signatures for this particular project? Or perhaps it's about different key lengths. Maybe choose an algorithm other than AES for a particular bulk data encryption. Perhaps though for others, cryptography is all about different lengths of keys and therefore strengths of crypto for different types of data. I think for me, though, ultimately your cryptography can only be as flexible as your ability to hold and indeed manage those keys, regardless of the algorithms or the key lengths. From a Thales perspective, there's really, I think, two forms of key management. There's the management of properties of keys, their expiry, their usage types, and then secondly, there's how you store those keys and control access. The secure storage and management of those encryption keys can be accomplished by hardware security modules, and the Thales Luna hardware security modules are what I'm going to take a moment to introduce now. And so here at Thales, we typically refer to hardware security modules as roots of trust because they provide the foundational protection of cryptographic keys. Essentially, they hold on to keys and will only let authorized people use them. A HSM's job is to both generate and then securely store cryptographic keys and then subsequently carry out operations on those keys. from an organization's perspective, by storing keys within a HSM, your organization can be absolutely assured that only your authorized users and applications have any access to carry out operations with that key. And as a consequence, all security of data, and indeed the cryptography that controls that data, ultimately falls back to the quality and the security properties of the HSM that you are using. Turning back to our theme of flexibility, this, of course, means that your cryptography can only be as flexible as the hardware security module you're using. And this flexibility applies to both algorithms, key lengths, and as we talked about on the previous slide, but also the location and the deployment nature of your application. On our next slide, we will talk a little bit about some of the form factors that HSMs operate within and appear as, but then we'll go on to talk about how we can combine those flexible form factors to build what I feel is an incredibly flexible cryptographic system. And so Luna HSMs are available in 4 main form factors, which you can see on the slide here. We have PCI cards, which are often embedded into applications and embedded directly into server hardware. There's a network version, which can be accessed by any network connected application. And indeed, there's a small form factor option, which allows you to store the device in a safe or another secure storage location. And we'll talk more about that as we get onto some of our use cases. And this small form factor device is really ideal for long-lived root certificates. For example, for your organization's root PKI. Thales also has a cloud HSM service, and this also uses the exact same Luna technology, but is available as a very flexible cloud HSM. Next, these introduced, I'd like to talk about how these different form factors can be used together to build what we feel are truly flexible crypto systems, and then applications that have cryptography both right at their heart, but also are flexible enough to work with the hardware and the deployment choices that your organization has made. And so here at Thales, we talk about cryptographic systems which require flexibility a lot, as you might imagine, and be that algorithms, form factor, or indeed the location for our hybrid HSM use cases. And for us, a hybrid system is all about providing as much flexibility as possible to the applications that are using the cryptography components you have selected. And so from a Thales hybrid perspective, your choice of keys, crypto algorithms, key length, the form factor of your device, or even your preference to use public or private cloud computing, or indeed traditional on-premise infrastructure, we feel should have absolutely no bearing on the type of cryptography that you are able to use with your application. A hybrid crypto system should allow your application to carry out the cryptographic activities that you need, regardless of where that application is running. And indeed, it should be able to securely synchronize that key material across different locations as required by your particular use case. And to illustrate that a little bit more, if I move on to our next slide, you'll see here we have an architecture diagram that expands upon some of the concepts I've introduced so far. Over in the left-hand side of the slide, in the white column, we have on-premises infrastructure deployed to support local applications running within your organization. Overhead at the top of the slide, you can see 2 hyperscaler clouds in Azure and IBM, both of which offer Thales Luna HSMs as part of their cloud package. And then in the top at the middle, we have our own data protection on demand cloud HSM service. And as you can see from this slide, coupling all of these things together in the middle at the bottom is the Luna Universal Client. This is a common client software package which allows your applications to talk to a hardware security module entirely regardless of its physical form factor or indeed its location. So in our example here, the Universal Client will connect your application to a HSM running in Azure just as readily as one in IBM Cloud, or indeed our own Luna Cloud HSM. Simultaneously, it can allow you to connect to on-premise HSM equipment that you may have within your organization. And for us, I suppose the real power of this Universal Client is that all of these connections can be made simultaneously, such that an application I'm using could use both on-premises hardware and also a cloud HSM at the same time. And even more importantly, it can automatically synchronize cryptographic keys between the physical on-premise hardware and the cloud services. And this allows me to build extremely flexible and location-agnostic applications, but also have applications that can connect to multiple different cryptographic services simultaneously. And so to build and expand upon some of that flexibility that I've just talked about, and indeed the flexibility that this capability brings, I'll move on to the second part of our presentation, where we will dive into specific use cases and talk a little bit about applications for the capabilities that I've just outlined. So we'll start by talking about an example of combining on-premise hardware security module equipment with cloud HSMs. And then I'll turn to talk a little bit about how crypto flexibility can assist with reducing organizational cost by using cloud systems for development environments, and then physical hardware security modules for production environments. After that, we'll go into some details about how you can enable crypto flexibility between different business locations, for example, different office locations, or indeed different data center arrangements. And then we'll move on to talking about some backup capabilities that are unlocked by the crypto flexibility that we've talked about. I'll go into some details about how you can protect your physical on-premise stored cryptographic keys with a cloud service, and also cover the inverse scenario as well, whereby you may have keys that live in a cloud environment today, and you would really like to maintain a physical copy within the control of your organization, a copy which you can keep in a secure location of your choosing, such that if the cloud service were to become unavailable or inoperable for any reason, you still have a copy of your most precious cryptographic keys, which of course ultimately protect and unlock all of your organization's data. So let's look at our first flexible and indeed hybrid example. And for me, this is really the building block for all of the other things that we will be talking about regarding flexible crypto and indeed deployments of HSMs or hardware security modules. So in this example, we have a single application instance, which is talking in parallel to both on-premise hardware security equipment and also to cloud hardware security modules. In this scenario, that same application is able to access keys in both locations simultaneously. And indeed, the key material is synchronized automatically between the on-premises infrastructure and the cloud service also. For me, there's a number of benefits from deploying this relatively simple setup. And that's essentially you couple yourself to the cloud services availability. So in the case of our Luna Cloud HSM, the service level agreement we give on that is a 99.95% uptime. And with that, you also get the cloud services backup capabilities. So in this example here, your crypto keys, which typically would normally live just in your on-premise hardware, and you would be then responsible for backing those up and storing those backups in a secure location. Those crypto keys now live in the cloud HSM infrastructure, which of course is massively distributed. And this means that you have the real-time backup capabilities of our cloud HSMs, protecting all of the keys for your infrastructure. I should also mention, because I think it's really important, that Thales has absolutely no ability to access any of the key materials stored within our cloud HSMs. And so some of the properties of this infrastructure are that if any failover happens automatically between on-premises equipment and the cloud HSM, so if you have any outage, network outage, power outage or similar for your on-premise equipment, then your application traffic would automatically fail over to the cloud HSM. And similarly, the inverse is true. In the hopefully extremely unlikely event that you cannot access the cloud service, then your on-premises equipment would take over the load. And this hybrid infrastructure will and split deployment model works really well for organizations who have high availability needs, but also a preference or a requirement for extremely low latency, which is often a problem when we're talking about cloud applications. The on-premises equipment will provide the extreme low latency in a way that any cloud service today realistically cannot, where you have split deployments. That is, unless, of course, you tie yourself to only ever running your application in that one single cloud provider's infrastructure. And of course, with the theme of this talk being flexibility, I'd argue that any crypto design that ties you to a particular set of infrastructure is maybe not optimal for your organization in the long term. So let's talk a little bit now about using cloud environments for development, and then physical hardware for production environments. And so this scenario takes advantage of the universal client technology, which I introduced a couple of slides ago. So here we have an organization that has a number of different development and test environments. And those test environments are used on the way to an ultimate deployment within production. This particular organization, in our example, has chosen to use the cloud HSM capabilities in their development and test environments. And then they use physical HSMs in their production environments, and then their staging environment also, such that that is as close to production, as close to live as is possible. And so using the universal client, they are able to develop one set of software for their in-house applications. And against that single universal client, all of their application calls to their crypto infrastructure operate. And then essentially behind the scenes of that universal client, the organization can use whichever form factor of hardware security module is most appropriate for them for that particular environment. So in this case, for development environments, they use the cloud HSM, and it's very easy for them to spin up a new development environment as a consequence. They can very quickly configure a cloud hardware security module, and they know that they've got the real HSM technology that they'll be using in production underpinning their same development environments. And from this organization's perspective, this greatly cut a lot of their complexity. They were previously using different crypto libraries and different environments with, I'll say, unsurprising incompatibility as a result. As they roll through their test environments, ultimately on the way to production, they know that they're testing against the same thing each time, so they have a higher confidence that they will see success as they move through their environments, and their release cycle is reduced as a result. But it also means that within their staging and production environments, they can start using real hardware, but with zero need for code or configuration change as a consequence. So to, I suppose, provide a little bit more detail, let's zoom in a bit more on the diagram from the previous slide. And here you can see that the organization we're discussing has a number of different development environments, as you'd expect for their different development teams. Then they have an integration environment, a regression environment, and all of those today are using Cloud HSM as their crypto service. But because of the universal client, they do so with the confidence that it's essentially exactly the same integration point as when they then move into staging and production over on the right-hand side of the slide, where they're using real physical hardware. And again, for this particular end user, the ability to spin up multiple development environments almost at will was really important. So this organization is a DevOps-centered company, and they wish, as a consequence, to be able to very quickly create new development environments almost at will for their DevOps teams. The universal client compatibility, and indeed the ability to spin up new cloud HSMs via an API, and therefore do this programmatically, allows them to create different environments pretty much at will. And so, as we show here, essentially they're able to create n different development environments, all with real HSMs underpinning them. And this allows the organization the DevOps flexibility they need as they're going about their daily business, developing their in-house systems, and ultimately pushing them through their normal pipeline through to production. Finally, on this use case, I should also call out that although our diagram here shows that the production and staging environment use physical HSMs, or indeed they could, if they wished, use a cloud HSM if that's appropriate for their particular use case. Without wishing to labor the title of the presentation, obviously flexibility is absolutely key. And so for your organization, It's absolutely critical to be able to design an infrastructure that's right for you. And that might be that you have physical hardware throughout your infrastructure, or maybe you're fully cloud, or you're a mix of the two. Needless to say, any of the environments that are shown here on the slide could have either physical or virtual cloud services hardware plugged in at any point, or indeed changed as well. Let's move on to our next use case now. And our next slide talks about using hybrid capabilities between different business locations. But as I mentioned, this can equally be extended to talk about hybrid between different application execution locations as well. And so in this scenario, we have a primary application instance, which is talking to a physical on-premise hardware security module, and then secondary instances of that same application, which are using cloud HSMs. Synchronization is happening between the HSM clusters, and that all flows via the universal client, which I've mentioned at length now. And this hybrid deployment scenario allows an application running at, say, a head office location to access on-premise crypto hardware, and that's potentially where the need is greatest for the absolute lowest latency. But then other application instances, maybe they're at branch or satellite offices, they can use the cloud service because the throughput or latency needs are less critical. And so those applications running at those local sites reach out to the cloud HSM for their crypto needs. But as I mentioned, this could equally be applied to organizations using containerized applications, as per our previous example. So you can have primary instances configured against physical HSMs to serve most of your application traffic, but then you could have a bursting scenario, or a scenario where you're deploying additional containers for whatever reason for a particular project, or a test cycle that your organization is going through. And you can do so against the cloud HSM. And as mentioned again on the previous scenario, where we had different development environments, but development environments using the cloud HSM, there's an API which allows you to deploy new instances programmatically. So you can spin up a new container, bind it to a new or existing HSM. And this gives you, I think, significant flexibility in the way that you can design and deploy your applications as they use cryptography, be they containers, microservices, or indeed a traditional monolithic application. Any of these things can be set up to talk to this universal crypto client, and from there, you've essentially got full flexibility with your choice of supporting crypto module. So turning back to our different business location scenario here, one really nice thing about this flexibility is that you don't need the full capital expenditure commitment of on-premises infrastructure if you're setting up a new office location or a new data center. And this means for me that strong cryptography with really secure key management is available even to the smallest of projects without that significant capital expenditure need. And so let's turn now to our final two scenarios, which rather than application execution, are instead concerned with flexibility with regards to the cryptographic keys themselves, in particular around their backup and protection. So the first of those scenarios is using Thales Lunar Cloud HSM's backup tile capability to take a backup of existing on-premise HSM hardware. And I think there's a couple of reasons why your organization might consider doing this. So firstly, as mentioned previously, Thales has absolutely no access to the key material that's stored within our cloud HSM that we offer via our Lunar Cloud service. And the same is also true for the dedicated backup capability, which runs within that same platform. And this means that you can upload keys to the Thales Cloud service, confident that only you as the end organization can actually access those keys. But the benefits in carrying out that upload are that you automatically transfer the burden of making sure those keys remain available and indeed protected from any form of loss or natural disaster. You transfer that burden back to Thales. And from my perspective, in doing this, this can be a significant part of your business continuity plan for how you protect your cryptographic keys, and of course, by extension, your most critical data, because I assume that you are not encrypting data unless it is important to your organization in some way, shape, or form. And so in I'll say a traditional organization deployment using hardware security modules, you'll back up a hardware security module to another hardware security module often one of our small form factor backup devices, for example, that we mentioned back at the beginning of the presentation. This device then gets securely stored, often in a fire safe, or ideally there will be multiple backups stored in different locations. So maybe you choose to use a bank safety deposit box, or at another business location of your choosing, a remote office location, for example. Again, you put that in a secure location such as a fire safe, because the reason for all this precaution is that your cryptographic keys ultimately govern the access to your data. And so by building on the flexibility elements we've already talked about, you can use our backup service with confidence that Thales has no actual access to your cryptographic keys, but gaining the confidence that your backups will always be available for restoring in the hopefully extremely unlikely event of a disaster that requires your business continuity plan to be invoked in some way. Similarly, we have customers who choose to use this backup service as their main backup capability because it just removes a management burden for them. They don't have to have a team of people looking after backups and fire safes, taking them to remote locations, coming together as a M-event group of individuals in order to perform a backup or a restore operation. And so this removes a lot of organizational complexity that is otherwise almost inherent in good crypto management and I'll say key management hygiene standards. And so finally, for our use case scenarios, we'll move to looking at, I'll say, almost the inverse scenario, whereby you can use a physical device, physical HSM, to take a backup of a cloud HSM. And for me, I think this is a really powerful example of flexibility in action, in that I may choose to be a fully cloud organization and use cloud services for all of my compute offerings. And that, I think, includes and extends to my hardware security modules as well for many organizations. However, because the criticality of those cryptographic keys that live inside those hardware security modules, I, as an organization, elect to maintain a physical copy of that key material so that I know I have it within my possession rather than it essentially living in the ether within a cloud service. And so the capability I'm outlining here allows you to use our cloud HSM for all of your HSM requirements for your applications, but you can take a backup of that key material that lives normally within the cloud, and you can take that and store it on a physical HSM. And that can be any of the form factors that I talked about back at the beginning of the presentation. But typically, you'd use a dedicated backup HSM in order to do that. And then that backup HSM, its small form factor allows it to be stored in one of the secure locations I mentioned, a fire safe, a safety deposit box. And so essentially, your organization can have the security of knowing that even though you're fully cloud, you still have access to the crypto keys that protect all of your data. So I think to conclude on these backup scenarios, the two different methods I've outlined, they're almost direct opposites of each other. One's a backup to a cloud service, the other is backing up a cloud service to physical hardware. But with either option in mind, though, this is really about what is right for your organization, what is the correct thing for your organization's design. And I think for me, this speaks to the flexibility that's been the theme of our presentation, in that whichever of the options I've outlined is right for your organization, or maybe there's a different mix of the capabilities I've outlined that does work for your organization and your cryptography. I think what's really key is that whatever you use is flexible enough to work for your particular organization's architecture and designs. And I'm very conscious that what is right for one organization might not be appropriate for another, and for extremely valid and important reasons. No two organizations are alike. And indeed, I know that even within an organization, what is right for one project might not be the correct architecture or series of decisions for a completely different project, even within the same organization. I think ultimately, though, as long as the tools that we choose to use, and indeed the cryptography and data protection they enable, give us the flexibility we need to build the architectures that enable successful companies, then we as information security professionals are really succeeding in our roles. And so I hope there's one or two takeaways from the presentation today that will be really useful in your role as you're building information security architectures within your organizations. And so that brings me to the end of my presentation today. If you're interested in learning any more about the topics I've discussed, you can find links on the slide here to a wealth of materials really that go in depth into the topics we've covered today. And I'd like to close with thanking you very much for taking the time for me to listen to me today. I really appreciate it.